Okay, now looking at the difference in electronegativity only tells us whether or not a bond is polar or nonpolar. But we can't use this to predict whether a molecule is polar or nonpolar. In order to predict whether a molecule is polar or nonpolar, you must draw it in its correct geometry. Now, if you haven't watched the video on drawing molecules in the correct geometry, then you need to go back and watch that video and then come back and watch this video. But let's take a look. If you watch that video, let's see how we can figure out whether a molecule is polar or nonpolar. Well, let's take for example, the first molecule up top, carbon dioxide. Now, in order to figure out whether a molecule is polar or nonpolar, we must draw in vectors, or the arrows that shows us where the electrons are pulled in the molecule. So in order to do this, I first must find my polar bonds. So if I look here, carbon and oxygen, if I do the difference in electronegativity, I will note that that is a polar bond, and oxygen is more electronegative. So electrons will be pulled towards the oxygen. Now, over on this side, because oxygen is more electronegative, electrons will be pulled towards this side as well. Now, if you notice that we have vectors that are pointing in equal and opposite directions. So it's like having two people on the end of a rope, and they're both pulling in equal and opposite direction with the same force. Well, the rope will go nowhere. So since the electrons cannot be pulled to either side because they're pulling with the same force, this molecule is nonpolar. Now, let's take a look at another example. Let's take a look at water, for example. Here we have water. We have a hydrogen-oxygen bond. And if you look at the difference in electronegativity, you will see that it is a polar bond. Electrons will be pulled towards the oxygen because oxygen is more electronegative. Now, to figure out whether the molecule is polar or nonpolar, what we have to do is we have to add vectors together. So if I add two vectors together, my resulting vector will be in the center of the two vectors. So if I add these two vectors together, and I'm going to make it long just to show that this is my resulting vector. So if I add these two vectors, the resulting vector is in the center. And this tells me that electrons are being pulled towards one side of the molecule. So therefore, this molecule is polar. Okay, now let's take a look at another example. This example here, we have carbon bonded to chlorine and another chlorine. These are our polar bonds. And we're going to draw vectors for only polar bonds. So, if I draw my vectors in here, chlorine is more electronegative than carbon, and this chlorine is more electronegative than carbon. So, if I add the two vectors together, my resulting vector will be in the center. So, there is nothing opposing these two vectors. So therefore, this molecule is polar. Now, from the early example, when we looked at dichloromethane, if we didn't draw it in this correct geometry, and we just drew in vectors, what this would show is that this molecule is nonpolar. However, if you draw it in its correct geometry, you will see that this molecule is a polar molecule. So, make sure that when you're determining whether something is polar or nonpolar, you draw it in its correct geometry. Let's take a look at another example. What if I had, let's say, B, let's say F3, boron trifluoride. And I wanted to know whether the molecule was polar or nonpolar. So the first thing I'm going to do is I'm going to draw in my vectors for my polar bonds. Drawing in my vectors. Now, if I add two of my vectors, I'm going to add the top two. Doesn't matter which two you choose to do. If I add my top two vectors, the resulting vector from these two vectors will go straight up. But you notice that I have another vector that's pointing straight down. So therefore, they cancel each other out. So this molecule would be nonpolar. Now, last but not least, let's take a look at this molecule here. We have carbon tetrachloride. And I have 4 polar bonds. So I'm going to draw in vectors for the polar bonds. Chlorine is more electronegative carbon, so therefore the bonds point towards the chlorine. So when I add these two vectors at the bottom, I will get a resulting vector, and I'm just writing it longer than the other ones to show us the resulting vector. I'll get a resulting vector that pulls straight down. Well, if I add these two vectors, I will get a vector that pulls straight up. If you notice, these vectors are moving in equal and opposite directions, so we would say that this molecule is nonpolar.